Good morning to one and all present over here. I, Miss Vaishnavi Deshmukh, welcome you all on behalf of Chemical Engineering Department. I would like to introduce you all to our today's guest, Mr. Ajay Satpute sir, who is the Managing Director at Converge Energy Engineering Private Limited for our today's guest talk on the importance of process simulation in our career journey. I would like to tell you, sir has published two books which are the best sellers. One is the compressor surge analysis, and second is the process plant design and simulation. We welcome you, sir. I request you to please start with the lecture.
All right. So first of all, thank you everyone for giving me this opportunity. So I'm Ajay. I'm the founder director of Converge Engineering Private Limited. So basically, what we do is we are a typical engineering consultancy. We do field studies, concept studies. We do detail engineering. We are very good in solving plant problems, and we also provide the corporate training for the process engineers. Um, Recently, we started selling Aspen software in India, and we are the sole distributor of fluid flow software in India and in Middle East. So as someone mentioned that I written two books. So this is the first book. This is my lockdown product. And with this book, one can learn Aspen HYSYS, not just steady state, but the dynamic simulation also. Um, and this is for a very good resource for doing the plant design. This is the second book that was published last year in May. This was the anti-surge wall sizing for the centrifugal compressors surge analysis. All right, so I'm a trainer also. I have trained over 3,000 process engineers in last 7 years with respect to simulation software, like Aspen HYSYS, Fluid Flow, FlareNet, etc. So three of my students are PhD, and I have trained from freshers till retired chemical engineers. So there is one YouTube channel that we have. A lot of process-related videos are available. So if you are interested in process, so this is the YouTube channel that you need to subscribe to. And if you want to learn fluid flow software for free, so the 4-hour training session is available free of cost. So once you start watching this, you will find there are the links available to download the software, which will work for 14 days as it is trial version. And recently we had completed one series on industrial accidents and how to prevent it. So all the major accidents that we have covered, right from Bhopal tragedy till recently what we have seen in Dombivli. Yeah, so long story short, I am perfect example of this. Right? So I'm going to tell you what you need to do in your life as a process simulation engineer. So the career opportunities for a chemical engineer in process simulation. Yeah. So where a chemical engineer can be placed as a process engineer with simulation software expertise. So you can work in an engineering consultancy like Worley, Technique, or Converge. You can be an R&D engineer working for BARC or ISRO or any other research institute. You can work as a process engineer in operating companies, technical services department as a process engineer, or you can be a production engineer in an operating company, or you could be a faculty in an engineering college. But if you want to get into simulation part, then probably the production engineer and then faculty, so that is not for you. You would rather be a process engineer in a consultancy or R&D engineer, or you will solve the technical problems in your plant in the technical services department. Right, the skill set required is basically this process engineering, nothing but process calculations. You must be excellent with respect to calculations. And the skills required for the career in process simulation, your engineering concept must be clear, right? So no subject should be kept on as an optional subject, right? You have to study 100%. You need to hone your analytical skills, right? Because the process engineer solves the problem. So your problem solving, you should have that problem solving attitude, right? And you must have the attention to details. If any scope of work document is given to you have to make sure that you read it thoroughly, okay, without missing any sentence or any paragraph. You must be an excellent engineer who can work in Excel, MS Excel, and your VBA, Visual Basic Skills, should also be honed, right? So if you want to become a process engineer or excellent process engineer, you cannot bypass Excel. Okay, you have to become expert in that, and then only you can become an excellent process engineer. And of course, the simulation software proficiency must be there. So all the relevant software like HYSYS or EDR or Fluid Flow or PipeNet. So all the software, you must know how to use it. So the question is, do you need to be a class topper to excel in process, right? So the short answer is absolutely not. As a process engineer, you must be a hardworking person. The class toppers, basically they excel or they do very well in research field, okay, or they could be a very good teacher, okay, they'll work as a faculty in an engineering college. But if you want to be a process engineer in a consultancy or you want to solve the plant problems, then you don't really have to be a class. I mean, you don't have to be a smart person. Okay, if you are hardworking guy, then it will help a lot. Make sense? Okay, so let us continue with the importance of process simulation. So can we do plant design using without using simulation software? Okay, that's the question, because you might be thinking that a couple of decades ago there were not many process simulation software, right? Computer were not even fast. Then also the people who were designing the plant, we can see several plants running very well till date. Then why do you need to use simulation software today? Right? Valid question, right? The answer is water plant that you must be seeing, which were designed without the aid of simulation software. So they were all over designed. Okay, multiple times over designed. So the cost of those plants would be much, much higher as compared to what you would get after using the simulation software. So it is not possible to do the plant design without the use of simulation software like Aspen HYSYS or EDR, etc. You have to have simulation expertise to do the plant design these days. We'll take one example. So the reactor needs benzene as one of the reactants, right? And what is the flow rate that we want? It is 30 meter cube per hour. And at what pressure we want? At 4 bar gauge pressure, right? So where from we are going to get the benzene, which will be sent to the reactor for further reaction? So there is one vessel, benzene storage vessel, and that is operated at 1 bar gauge pressure. You can see the operating pressure is 1 bar gauge, and from 1 bar gauge pressure, we want to push that benzene to 4 bar gauge pressure. So how the pressure increase is going to happen? Pressure is going to rise because of the pump, right? So there is pump sizing required. Then for the pump, we need to have the pump suction line. Okay, there will be pumps discharge line. And we want 30 meter cube per hour, so flow rate has to be measured. How we are going to do that? There'll be a flow meter. We are using, say, flow orifice. So we need to size this flow orifice. We are going to maintain certain level in this vessel, let's say 60% liquid level. So what is going to make sure that level is not 0% or 100%? So we have this level control valve. So this sizing will also be done by a process engineer. So there are whatever number that you see here, okay, all the ABC. So that is coming from following some process standards. And good thing is what we need to do, what line sizing criteria or control valve sizing criteria, or even orifice sizing criteria are to be used. It is all available in those process standards. And fortunately, there are only less than 10 process standards that a process engineer has to use. Once you are thorough with this, right, let us say API 14E, line sizing criteria are given. So what is the pump suction line sizing criteria, or pump discharge line sizing criteria? If it is a gas line, so what should be the maximum velocity? So that is again a different line sizing criteria. If it is two-phase, then comes the erosion velocity criteria. So all these things are available. So the thing is, you need to read it and understand it. And that is the reason, as I said earlier, to become an excellent process engineer, you don't have to be smart. You have to be hardworking, because the same thing you are doing it again and again. So eventually, after a couple of projects, you become expert in that. For the third project, you don't need anybody's help. This makes sense? Right. So once we have used all these standards and we have done our calculations as per the guidelines given in those standards, so using the Excel file also we can do this, right? But if you use the simulation software like Aspen HYSYS, okay, this is a screenshot of the Aspen HYSYS model. We can do the same thing, but in a lesser time and more accurate, because at every point we can get the physical property of every stream, every material stream. So we would know what exactly we know what's happening in that particular plant. Yeah. So in this case, simulation software like Aspen HYSYS usage is not required, as the design is quite simple. So that's why let us make things more complicated, right? So you know this product is one of the most widely used product, petrol. Where from we get this? Who manufactures it? Refinery. And what is the raw material for this refinery? Is the crude oil, correct? So what any industry objective would be to take the raw material and then convert that into useful products, correct? So in this particular case, crude oil is our raw material. And from crude oil, there are different products that can be extracted. Okay, right from this bitumen, diesel, petrol, kerosene, LPG, right? So you must be wondering why exactly these refineries would do this hard work. Is they will take the crude oil and then produce petrol and other products. Anyone can tell what is the purpose? Do they do for for the society, for the benefit of the society, so that people can run their cars and other vehicles, right? Absolutely not. Means that is not the reason. This is the only reason why refineries or any other company would produce something or manufacture something. It's all for the money. So process engineer would have technical aspects also intact as well as commercial aspects. He or she would know that if I do this, okay, if I design the plant in this way, whether the plant is going to make profit or it is going to be in loss. Make sense? Okay, so let us talk about this early production facility or EPF design. So how do the crude oil is taken out from the Earth's core or Earth's crust? So you're going to drill a hole, right? And then um, under the under the Earth's crust, so you will find the deposits of crude oil or gas or even produced water, and that will be in pressurized condition. So that will come out to the Earth surface through this pipe, and this will be sent to heat exchangers. It will be sent to the heater to increase the temperature of the two-phase feed. Here we are considering oil and gas. So it goes to the separator. So what is the function of the separator? To remove vapor, or we remove gas from the oil. And then gas will be sent to the compressor for the further processing. And that can be used as you can say the CNG or LPG, right? The oil, so that will be sent to through the pump. It will go to the flow orifice. Okay, then you will go to the LCV. then finally go to the preheater, and it will be sent to finally to the storage tank for storage, and that crude oil will be sent to the refineries for their further processing. So in this, what software one might use to do the design? Aspen HYSYS, right? And then Aspen EDR. EDR for heat exchanger sizing. Aspen HYSYS is for the process simulation. So this is the model that one can get for the same system using Aspen HYSYS. So we have this on-off valve, we have the pipe segment for two-phase line sizing. There's a flow control valve, there's a heat exchanger, shell into heat exchanger, then there's a heater package, then goes to the separator, and bottom you can see there is the pump, followed by flow orifice, LCV, and in the vapor line you might see here a pressure control valve. So whatever we have on the PNID, on the drawing, everything can be simulated using Aspen HYSYS. And this is the sheet that will come from the Aspen EDR. It would tell you how big the heat exchanger or the preheater, the shell into heat exchanger you need to design. So in this case, it is like 55 meter square heat transfer area. The tube length is say 6,000 mm. You can see number of tubes are 155. Okay, this is called as STEMA sheet. And it will give the mechanical drawing of the heat exchanger. This is the drawing for the tube sheet. So you can see how many tubes would be placed in the tube sheet. Right, so we can run this lead production facility in dynamic mode also. So the software required will be Aspen HYSYS Dynamics. Right, so I'll just click here to run it. So here you can see there is this flow control valve, okay, which is connected to flow controller. So right now the set point for the flow controller is 20,000 kg per hour. Right, for that the valve opening, the flow control valve opening is 82%, and it is maintaining 20,000 kg per hour set point. Now, if I change the set point to 18,000, then what will happen? The flow control valve has to be throttled. So it's opening from 80%, it will drop to maybe 70, 74%, right? And if I increase the set point from say 18,000 to 22,000, then again this valve opening would be increased. So you can imagine the power of the simulation software. I mean, you have not purchased a single nut bolt for that plant, but still you are able to visualize what is going to happen when the plant is in running condition, right? The equipment that you have designed, whether those are adequate or not, right? Whether there's going to be a bottleneck. Uh, if I increase the set point from say 20,000 to 22,000. So all these things, all these scenarios you can study before a single nut bolt has been purchased, right? So that's the reason it makes more sense for the operating companies to invest in the modeling using the simulation software, right? So that they can save a lot of money, in future, right? So there is something called a pinch analysis. The objective of pinch analysis to minimize or eliminate the utility. Utility means steam, thermic fluid, cooling water, chilled brine, etc., etc. Now, the one of the major reasons, most important reason why the operating company make loss is they spend a lot in the utility. So if you are able to say reduce steam consumption or reduce cooling water consumption or chilled water consumption, then the total cost, operating cost would be reduced, and sales minus cost, your profit would be increased. So there is this example we have, this two-phase feed. Okay, it is going through the flow control valve. Then directly it is going to the heater package and then to the separator. And finally, we wanted oil at 60 degrees C temperature. And we have here a cooler, right? We'll be using cooling water here. Now, this is the, let us say, existing system. So heater duty is 705 kilowatt and the cooler duty is 307. It means we need, for heating purpose, we need 1.2 TPH of LP steam and around 50 meter cube per hour of cooling water. And this cooling water would come along with cooling tower, cooling water supply pumps, the piping, instrumentation, control valves. Okay, and this LP stream, 1.2 TPH, LP stream would come with the boiler of the said capacity, right? The piping, insulations, all these things would come along with this. So the question we need to ask as a process engineer, is this the best design possible, right? So if I remove this cooler and the hot stream, let's say 85 degrees C, I'll send it to the new shell and tube heat exchanger and let us say tube side of it. And it will exchange the heat from the to the incoming 40 degrees C feed. So what will happen? 85 degrees C will give heat to 40 degrees C. 85 will become 60 degrees C. And it will go as it is supposed to go to the storage tank finally. So because of this, what's happening? There is 40% savings in the heater duty. And then there is 100% savings in the cooler duty. So you can imagine how much money we have spent, saved here especially for the cooling water side. Now there is no need to purchase any cooling tower, no need to purchase any cooling water supply pumps. Okay, no piping required, no instrumentation, no control valves. You can imagine at least 50 to 60 lakh rupees we have spent for this particular design. And what is the reduction in the heater duty? You can see 40%. That means the capacity of the boiler that we were planning to purchase, so that will go down, right? The operating cost to run that boiler is going to go down by 40%. So we're talking about huge saving in money. Using Excel calculations, it is not really possible to do this effectively, right? So that's why we have to take help from the simulation software. Okay, so to conclude, overall it will be a cheaper, better, more accurate design if you use the simulation software correctly. Okay, now the emphasis should be on the word correctly, because anybody can use the software, but how to use it in a correct way or the right way. Okay, so that is another story altogether. So which software you must know as a minimum? Okay, Aspen HYSYS is there, Aspen EDR is there, Aspen Flare System Analyzer or FlareNet is there, Aspen HYSYS Dynamics is there, right? There is Aspen Plus for hydraulic simulation. For the pressure calculation, you can use fluid flow software or PipeNet software. So to conclude, I would say that process simulation is the most interesting subject, right? But the catch is, unfortunately, no one can tell you how interesting this subject is. Okay, you have to see it for yourself. So if you have planned to become become a process engineer, then how to get started and excel? So you need to learn Aspen HYSYS, EDR, fluid flow software, right? That is number one. You need to get the professional training, because in your 4-year bachelor's day, whatever you learned, that is not really useful per se if you want to be used as a ready-to-use product in industry, okay, especially in the consultancy. So the formal training has to be there, because the industry spends a lot of efforts, a lot of energy and money to make the fresher like you, to make the freshers turn into a ready-to-use product. So whatever skills that will be required to become a good process engineer, so that you need to learn it from some professionals. You need to update your CV, right? Because if you have learned the software, then you have to make sure that you write that in your CV, so that the companies would notice that and probably ask you the questions on those topics. And if you really learn those softwares well, then you'll be able to answer their questions and get the job. Make sure that you update your LinkedIn profile, right? Make sure all the simulation related items are added in your profile, and you must get connected with a relevant professional, because you are all chemical engineers, right? So it doesn't make sense to get connected with the electrical or instrumentation or piping engineers, right? Because they are not going to give you job. And don't get connected with the junior people. Okay, means all the freshers or whose designation is junior engineer or just engineer. You need to get connected with the people who are having more number of experience, at least 10 years experience, so that they'll be the decision maker. If they have job, they can recommend you, right? And you need to keep posting the technical articles online on LinkedIn or any other uh, social media. Okay, so try to spend more time on LinkedIn, less time on Instagram, right? And must prepare well for the interviews. So I would always say that to get an excellent job as a process engineer, it's a 6 month project, right? You need to invest your time on LinkedIn, get connected with right people, and then keep posting the technical articles so that you are actually marketing yourself on the social media, right? And once somebody has a job, so he or she would think that this person is sharing a lot of useful stuff, right? Related to simulation software or the process design. So he must be knowing his stuff. And then you will be given priority, you'll be recommended for that particular job. I've seen many people who have got job this, by this route. So I would encourage you to be, you can say, be visible on LinkedIn. All right. So this is the final item. So this is the marketing of CPL's process design course. So if I have permission, I can do some marketing. All right. I'll go ahead. So we provide the process design training also. So we have total 12 session course, 12 session course. Every weekend there will be one
Okay,
session.
sir. Yes, sir. Just a minute.
Okay. So basically, first 4 sessions you will learn all the relevant process calculations, right? So how to do the line sizing, Excel, I mean using Excel, controller sizing, PSV sizing, pump sizing, separator, orifice. You will be able to do the plant design using Excel. So all the standards, relevant standards, you would know what formula needs to be used. So that information will be given to you. And once that is done, then you learn how to do those same and some additional calculations using Aspen HYSYS. You will also learn how to do the heat exchanger sizing using Aspen EDR, how to do the distillation column sizing, blow down utility you would learn, depressurization, you will learn how to do it using simulation software. And you will also get a training on the Visual Basic, right? Aspen Plus also you will learn. You will learn how to do the surge analysis using PipeNet transient software, how to use this fluid flow software. You'll become more conversant with uh, the dynamic simulation problems, because session number 11 and 12, okay, we talk only about dynamic simulation problems. You will also learn how to prepare the documents, right? Process simulation report, how to prepare the PFD from scratch, how to prepare the PNID, what needs to be considered, what are the things which are not important. So all this information would be given, and it will be a hands-on training, right? So basically, you learn what industry expects. You will figure out what a process engineer is supposed to do in industry, and this is purely job-oriented training. And we do provide placement assistance. Um, I don't believe any of my students who want job and is not having job, right? So, and many of my students I hire because I'll I'm more comfortable with them because I know that they have already completed the process design training, and they would know how to do the calculation, how to do the simulation, how to prepare the documents, right? And anyone who wants the job, I mean, any of my students who want the job, the one question I ask whether he has completed the homework assignment or not. If the answer is yes, so there is no interview. If I need, I hire. Okay, like that. Okay, and don't believe me, believe the Google, right? So there are 292 reviews. Take it some time, try to search Converge Engineering Google review and then read it on your own. Okay, so that's it from my side. Any query, any questions you have, please feel free to ask.
Just a minute. Hello, sir.
Yes, sir.
What is sufficient to learn Aspen Plus mathematician?
I didn't get your question.
Aspen Plus sufficient for plant design?
Are you asking Aspen Plus is useful for the plant design?
Yes, sir.
Okay, so Aspen 1 is the, you can say, the main, single product. In that product, they have 45 different modules. So Aspen HYSYS is one of the modules. Aspen EDR is there. Aspen Plus is there. Aspen Plus Dynamics is there. There is Aspen FlareNet is there. So like that, total 45 different modules are there. Aspen HYSYS is very much used and very widely used for the oil and gas industry, where the hydrocarbons are there, like methane, ethane, okay, LPG. So for those kind of system, Aspen HYSYS is very effective, I would say. But when you go to the chemical, specialty chemical, fertilizer, so those industries where basically solid handling is there, right? So these solids, HYSYS cannot really do well. So that time we had to use Aspen Plus, right? So we had done one project for Apex Carbonics, that is in UP. We had designed ammonium bicarbonate plant for them. So that particular plant we cannot simulate in Aspen HYSYS. So we had to use Aspen Plus. Aspen Plus has got centrifuge, it has got dryer, granulator. So many solid handling items are there. Screening is also there, right? So Aspen Plus has got, you can say, uh, it has got more features. It is more useful, but thing is that the people who are using the simulation software, HYSYS, so that is from the oil and gas background. So that's why whenever we think of Aspen, HYSYS is a name that comes. Okay, not the Aspen Plus. Okay, did I answer your question, or was I successful in confusing you more?
Hello, sir.
Yes.
Sir, as you mentioned the course, so is this online, offline, or
Yeah.
what is the cost for that?
Yeah, this is online course. Every Saturday and Sunday, we run the parallel batches. And fees, I think this time it is 51,000 something. And it keeps increasing after 3-4 months, I guess. Right? But at
Okay,
the
sir.
end of final session, I ask this question to my students. Okay, whether the money is good, but every time I get the feedback that I need to increase the fees, because what they are getting, that is a lot more than actually they are paying. So it is kind of paisa vasool kind of training, and it is very useful, not just for the freshers, but engineers who are already experienced 10, 15, 20 years. So they have also completed the course and they found it quite useful.
Hello, sir.
Yes.
So I want to ask you that, so when we do the course, after the getting some experience or at a fresher level?
So once you have completed your engineering, okay, you can enroll for that course.
Okay, sir. One more question is there. Just a minute. Okay. Sir, what about when we go for the online? Then is it possible to handle the softwares?
I didn't get a question.
Different softwares are there, Aspen, ICs, and different softwares are there. Then how it can handle online or what?
Handle online, what do you mean by handle online? So you'll install it in your system and then it will be hands-on training. I'll solve one problem, you'll solve the same problem. So once that is done, I'll go to the next problem. Okay, same procedure. It will not be a classroom training where I'll be doing stuff and you're just listening. Okay, that way nobody has learned the simulation. And certainly we are not going to do that in the class.
Okay, sir.
Okay, any other query?
I think, sir, no any query, but I will share your contact details to our students where they get the more idea about this.
Okay. Is there any question other than the course? Somebody wants to know, whether this process engineering really worth doing, or I would go get into the production. Yeah, yesterday afternoon, actually, I had the same session. I did it for Bharati Vidyapit. So that was offline. So I drove there. We spent quite a lot of time in this question and Q&A session, where the students they wanted to know which field is better, better in the sense what are the challenges in each field, whether it is production, R&D, right? So that's why this face-to-face interaction is very important. So right now, I don't know how many people are sitting there, okay, behind the laptop. All right, great. So anyone who wants to get into production, can you raise your hands? I can see you guys. Anyone want to get into production as shift in charge or plant supervisor? You can raise your hands. Okay, nobody? Okay, only one guy. Okay, my suggestion would be don't get into production because it will take at least 5 years of your life. Because you're a chemical engineer, you'll have to work in chemical industry then, right? It is not really a healthy life, right? It is quite risky also. So the best job would be to become a process engineer in consultancy. Okay, why? Because you will get to work in an AC office, right? You will have a large lifespan, I would say. Correct? You'll have better money, right? Anyone who would like to go and get into the research, R&D, you can raise your hands, please. R&D. Okay. So I can see only one girl who is interested in R&D. Okay. So when you have decided that you want to get into R&D, okay, please make sure that you get all the background information about that because you need to do the PhD. Correct? You'll have to spend quite of uh, several years of your life studying, right? So you have to be a studious person, correct? And where exactly we want to get into, let us say if you want to, right? So you have to find a company. If you want to really get into research, you need to find a company who has a lot of money, right? To do the research work, right? Because probably you will be doing the same research for rest of your life. So you have to make sure that you do something good, right? So just because your friend is going to R&D, don't go to R&D. Right? The decision should be yours, and it should be a very after thinking a lot, you must come to that conclusion that you want to get into R&D. Make sense? All right. Any other query anyone has? Garda students don't talk much. All right. So, Mabara sir, if nothing
Yes,
else,
sir.
I think we can conclude.
Yes. Yes, sir. Just a minute, sir.
Hello.
Yes.
So good afternoon to all of you. I'm Malik Malani from BE Chemical Department. I'm honored to deliver the vote of thanks for today's process engineering session. First, I extend my heartfelt gratitude to our esteemed speaker, Mr. Ajay Satpurti, sir, for sharing their invaluable insights and expertise related to process engineering. Your contribution have grateful enriched our understanding of the field. I also thankful the organization committee for making the event success. A special mention goes to all participants for your engagement, which made this session memorable. So, thank you, everyone.
All right, thank you very much, especially Mapara sir, for arranging this. I'll be sharing one WhatsApp group link. Okay, you may share that with your third and final year students. So if they need further assistance, further guidance, okay, they can contact me directly. All right.
Okay, sir. Sure, sir. Definitely.
All right. Thank you. Have a nice day, everyone.
Thank you. Thank you so much, sir.